Since 1964, we've had this idea proposed by Englert, Brout, and Higgs that empty space is like a medium. And as particles travel through this medium, some of them interact with it, some of them don't interact with it. The ones that do interact with this medium, they acquire masses, and the ones that pass through it without interacting, those are massless particles. The Higgs boson has this job of giving masses to all the other elementary particles. If you look at the basic equations of the Standard Model, as written on my t-shirt, they're very symmetric. The way in which all the different particles appear is the same. At least on the top two lines, there's nothing to distinguish particles which have different masses, for example. But this symmetry has to be broken. Electrons are lighter than muons. The top quark is much heavier than the quarks that make up everyday nuclei. So the top two lines, the symmetric lines, cannot be all there is. There has to be something to distinguish between the different types of particle. And that's the job of the Higgs boson.
The Higgs boson is a particle which is a leftover excitation of the Higgs field, which in turn was needed in the Standard Model to 1. Explain the weak nuclear force, and 2. Explain why any of the other particles have mass at all. However, the boson is the only bit of the Higgs field which is independently verifiable, precisely because the other bits are tangled up in the weak nuclear force and in giving particles mass. The fact that the Higgs boson is so independent from the rest of the Standard Model is why it's the last piece of the puzzle to be discovered. And if it turns out to be exactly what was predicted, the Standard Model will be complete. The only problem is that we know the Standard Model isn't a complete description of the universe. It entirely misses out on gravity, for example. So to physicists, it would be much more interesting and helpful if the Higgs boson turns out to be not quite what we expect. Then we might get a clue as to how to reach a deeper understanding of the universe. So even though we just made a discovery, we can't sit back and relax. We need a hint, Mr. Higgs.
This is a very, very preliminary result, but we think it's very strong. It's very solid. Otherwise, we wouldn't present it.
Should I say that I'm pleased?
Congratulations.
I think it's obvious.
This is still mine, right?
This is still yours, yes.
As a layman, I would now say, I think we have it. You agree? Yeah.
Thing there. To say you've discovered the Higgs, it's a complicated story. It's one thing to see evidence of a new particle, but you have to check whether it has the right properties. And to check whether it has the right properties will actually take quite a bit of extra work. Carl Sagan once said that extraordinary claims require extraordinary levels of proof. Before we can say that we have discovered the Higgs boson, we have to be absolutely, absolutely sure. And that will probably take a bit more time. But I expect that by the end of the year, we will be absolutely certain, one way or the other.